Hello everyone and welcome back to another video in the Introduction to Windows Forensics series. This time we're going to take a look at the ubiquitous LNK or link file, as well as a lesser known Windows feature called JumpLists. So I'm guessing you're already familiar with the former, as link files or Windows shortcut files have been used in the Windows operating system for a very long time. A link file is simply a metadata resource used by the Windows shell. On the screen, you'll see an article from the Forensics Wiki that provides a nice high-level overview of this particular artifact, including information about the file format and the metadata associated with it. It also mentions the file signature or magic number for LNK files, which is 0x4c or 4c000000. This is useful if we want to carve for LNK files, which we often do. So chances are you've manually created a shortcut at some point to a program or document, and of course it should come as no surprise that when you do that, you're creating an LNK file. But did you know that Windows also automatically creates these files on a very frequent basis? For example, when you open a document, be it local or remote, a link file is automatically created. In fact, link files are also automatically created under numerous other circumstances. Now, you might assume that there wouldn't be much forensic value in a simple shortcut file, but you may be surprised to learn that within those files, an investigator can expect to find the following items of interest: the original path of the target file, the timestamps associated with the target file, as well as for the link file itself, the size of the target file, the attributes associated with the target file, for example, read-only, hidden, system, etc., the system name, volume name, and volume serial number, and sometimes even the MAC address, yes, the MAC address of the system on which the link file is present, and information indicative of whether or not the target resource is local or located on a remote computer. Additionally, the creation time of the link file itself will usually indicate the date and time that the target file was first opened, and the modification time will usually indicate the date and time that the target file was last opened. Also, remember that even if a file has been deleted, or even securely deleted, a link file pointing to that resource may still be present on the system, and parsing that would give us all of this information about that file, even though the file itself may no longer be present. The next article I'll show you is from Magnet Forensics. It's entitled Forensic Analysis of LNK Files, and it goes into a little bit more depth on this particular artifact. I'll include a link to this in the video's description as well, and I would highly suggest that you review it. Next, we're going to talk about jump lists. So, jump lists were introduced with Windows 7. Have you ever right-clicked on a program in the Windows taskbar and seen a contextual menu that pops up? In fact, it looks just like this. This is a jump list. It was designed to provide users with an easy way to access recent documents associated with a particular program, as well as common tasks associated with that application. So it turns out that there's two primary flavors, if you will, of jump lists used by the operating system. One is called automatic destinations, the other custom destinations. Now this all happens behind the scenes, and this kind of data is not directly presented to the user. But these two flavors of jump lists are stored in files with extensions of .automaticdestinations-ms and .customdestinations-ms, respectively. The former contains jump list features provided by the Windows API that are common across all applications, whereas the latter, custom destinations, provides application-specific features that can vary depending on how the developer of a given application has chosen to implement them. So as you might imagine, most of the time we're going to focus our investigation on the automatic destinations jump lists, but you need to be familiar with both and know how to parse both. Automatic destinations are actually object linking and embedding, OLE, compound files, CF, which is collectively referred to as OLECF. This is a proprietary technology developed by Microsoft that allows multiple data streams to be stored in a single file. This is also referred to as a compound binary file, and they're used extensively within Microsoft Office documents. So basically think about a file that contains multiple files within it. In the case of automatic destinations jump lists, each stream is actually its own link file, which means that if we extract the streams, we can parse the link files like we would a normal link file. But the custom destination link files, however, are different. They are usually created when a user pins a particular program to the taskbar or start menu. They are not in OLECF format and do not contain streams. They instead contain the shell link structures, the link file structures, in a sequential format, one right after the other, kind of smushed together in a single file. We can actually use a file carving utility to carve out the link file data from a .customdestinations-ms file. Alternatively, we could also use a hex editor to examine those files as well. Now, like all the other Windows features we've looked at in previous videos, both link files and jump lists were not included in the OS to aid forensic investigators, but we're sure going to take advantage of them because there's a wealth of forensic data associated with them. So next we're going to switch over to our Windows 10 Analysis VM, and we're going to take a look at where in the operating system we can find these artifacts, and then we'll look at the various tools available to us to parse them. So let's get started. Okay, so the first question we need to answer is, where should we look to find these artifacts? Where will we look to find link files and jump lists? Well, as you might imagine, link files are scattered throughout the Windows file system and can be located in any number of places. In fact, it's not uncommon to use a tool like FTK Imager to create a custom content image to grab star.lnk from a drive so that we would have all of the link files available to us to forensicate. That said, most of the data that we're going to be interested in is going to be located in one of two different places. I'm currently in Users, My Username, App Data, and in this path we see the three folders we would expect to find underneath App Data: Local, Local Low, and Roaming. As a quick refresher, in the Windows XP days we had Documents and Settings. Our user profiles were stored underneath that location, and then underneath the user profile we had Local Settings and Application Data. Now we have Users, the user profile, and underneath that, App Data Local, App Data Roaming, and App Data Local Low. App Data Local maps to what was Local Settings in Windows XP. App Data Roaming maps to what was Application Data in Windows XP. And App Data Local Low has no equivalent in Windows XP. Local Low, by the way, is a place where low integrity processes can store data, things like Internet Explorer running in protected mode. We're going to be interested in Roaming, Microsoft, Windows, and Recent. You'll notice it says Recent Items in Explorer, but the actual path, as you can see here, is Recent. So again, the full path is Users, Username, App Data, Roaming, Microsoft, Windows, Recent. And in this location, you'll see 38 items, which at first glance appear to be a combination of JPEGs and Excel files and zip files. However, they're all of type shortcut, and they're all about 1K in size. If we spin up a command prompt here and take a closer look, you'll notice they're all LNK files. And for example, we've got capture.png here, which is actually capture.png.lnk. Now, with Windows 10, the actual extension of the target file name is included in the name of the link file. Prior to Windows 10, this file, for example, would have been capture.lnk, but now it's capture.png.lnk. So again, the extension is included in the name of the link file. So that's an important change starting with Windows 10. Now, what about the other location that we would find link files? I mentioned there are two primary locations. Well, the other is under Microsoft Office Recent. And again, that full path is Users, Username, App Data, Roaming, Microsoft Office Recent. So you'll certainly want to grab the files located here as they would pertain to Microsoft Office products. So again, those are the two primary locations that we would want to forensicate to find most of our link file evidence. So what about jump lists? Well, it turns out that jump lists are back in the original path that we took a look at, under Users, Username, App Data, Roaming, Microsoft Windows Recent. There are actually a couple of folders that you don't see in Windows Explorer. In fact, you'll see them here. We've got Automatic Destinations and Custom Destinations. Even if we turned on Hidden in System Files in Explorer, in my experience, these don't show up. So if I run dir/ad just to show directories, again, here they are. And within Automatic Destinations, we'll see the .automaticdestinations-ms files that we covered in the previous section. And under Custom Destinations, we'll see the .customdestinations-ms files. So next, let's spin up a bash prompt and take a closer look. Now, for those of you that have watched my previous videos, you know I am a Linux, Unix, Mac geek. So bash for Windows, I think, is an awesome feature, especially for forensic investigators. So I would highly recommend you check that out if you haven't already. So I'm in the same path, and I'm going to run file against one of these. And when I do, you'll notice it does find the shell link header, and it identifies this as an MS Windows shortcut, which is exactly what we expect. If I go into Automatic Destinations, and I pick one of these files, you'll notice it identifies it as a composite document file, v2. Now recall that automatic destinations are actually object linking and embedding compound files, OLECF, which is also known as a compound binary file, which is also known as a composite document file, so this is the same thing. So you'll recall that these files have multiple data streams stored in a single file. Now let's take a look at custom destinations. And we'll run file against one of these, and you'll see it comes back and just says data. That's because custom destination files are, of course, different. They are usually created when a user pins a particular program to a taskbar or start menu, but they are not in OLECF format. They do not contain streams, and instead they contain the shell link structures in a sequential format with one stacked on top of another, all smushed together. So that's why this doesn't really identify it as any specific type of file, just data. If we used Foremost or some other type of file carving utility, we could actually extract the link file data from these files. That's beyond the scope of this video, but it's something we might cover in the future. Now the last thing I want to show you before we move on to the next section is a tool called ExifTool. Now you may be familiar with EXIF data from JPEGs. For example, we could look at EXIF data to find latitude and longitude information present within pictures, for example. Now this tool can show us that, but it can also show us metadata associated with a wide variety of files. So if I run ExifTool without any options, just against capture.png.lnk, you'll see it comes back with a good bit of data. At the top, we see information pertaining to the link file itself, timestamps and the file size for the link file. But here, we actually see some interesting information about the target, the actual capture.png file to which the link file was pointing. We see the attributes, which are just listed as archive or A. We see the timestamps associated with the target itself, not the link file. You can see they're clearly different. This is September the 23rd, whereas this is October the 10th. We also see the actual size of the target. We also see the fact that it was located on a fixed disk, as opposed to a removable disk. We see the base path where the file was originally located, the working directory, and even the name of the machine on which the file was present. And as I mentioned in the previous section, sometimes even the MAC address of the machine on which the file was present. So all of this information is present. So again, just by running ExifTool, this simple tool with no options against one of these little 1K link files, or actually half a K in this case, we've been able to extract quite a bit of useful forensic data. Now in the next section of the video, we're going to take a look at a couple of tools from Eric Zimmerman to actually parse the link files. We're going to look at LNK Explorer and the command line version of that tool and actually go through and parse a few of the link files and see what kind of additional data we can extract from them. So let's go ahead and move over to the next section of the video. So as we just saw, it is possible to use ExifTool to parse link file metadata. But even if you scripted it, it doesn't scale well. If you had dozens or even hundreds of files to parse, you're going to want a different, more scalable solution. There are numerous tools, both free and commercial, that can help us parse both of these artifacts, link files and jump lists. As I said in the last section, we're going to be looking at two tools from Eric Zimmerman. The first of those tools is LNK Explorer, spelled LNK Explorer. This is a command line tool that is very easy to use. We can simply point it at a directory containing link files and it will recursively parse that directory of files and output the results in one of several different formats. So you'll see here that I have a command prompt open and I'm currently in the /tools/LNK Explorer directory. Now there's nothing special about this path. This is actually a standalone executable called lecmd.exe, so we can run LNK Explorer from anywhere. I've just chosen to organize my digital forensics tools in the tools directory. So if I run lecmd.exe without any options, we'll get the help output. So let's briefly take a look at each of these options. The D option can be used to specify a directory of files that we want to recursively process. The F option can be used to instead specify a single file to process. The Q option will suppress some of the output, and this is useful to speed up exporting to JSON or CSV files. The R option will only process link files that point to removable drives. The All option will process all files in a directory instead of just those ending in .lnk. The next 5 options are output format options. So we've got CSV, which is actually a tab-separated formatted results file. That's what we'll be using. XML, HTML, JSON, and then a more human-readable layout for JSON. And then the last 4 options are a little bit more advanced, where we can suppress target ID list details, we can suppress extra blocks information, specify custom date and time formats, and display higher precision timestamps. We won't be using any of those. So let's run lecmd.exe, and we'll first specify the directory that contains our link file. Since this is the live system, we'll just go into users, my username, app data, roaming, Microsoft, Windows, recent. We'll use -q to suppress some of the output to standard out, --csv to specify the format that we want the results to be written in, and then the directory to which we want those results written, which will be our current working directory, /. So if we run that, you'll notice that we get a message saying that it processed 45 out of 45 files, and it's already done. And here you can see the location where the results have been written. So let's load up Windows Explorer and browse to our tools directory, go into LNK Explorer, and here's our TSV file, which I've already associated with Microsoft Excel. So we'll double click on that file, and let's first clean this up a bit. So we'll size all the columns to fit, go ahead and enable filtering so we can filter the data, and we'll also, as a habit, freeze the top row, which is very useful if you've got multiple pages of output. So as an example, let's pick on our friend capture.png.lnk again. Now, as we scroll across here and look at the collected data, a lot of this you'll recognize from ExifTool, but there are a few additional pieces of information that we did not see with ExifTool. So first we've got the source timestamps for the link file itself. Then we've got the timestamps for the actual target, the actual capture.png file in this example. Then we've got the target's file size and its relative path, its working directory, the attributes, which again is just an A or archive, the header flags, which specify the type of data contained within the link file, the type of drive on which the file is present, which in this case is a fixed drive, the volume serial number, which we did not see with ExifTool. And in fact, if I load up a command prompt here and run vol, you'll notice that volume serial number does indeed match what we see here, because this is the machine on which that file was present. As we continue to scroll across, we'll see volume label, which is blank because there is no volume label on this particular drive. The local path for the target file. We'll also see some MFT related information, the name of the machine on which the file was present, the MAC address of the machine, which again I had mentioned previously, but we did not see with ExifTool. The MAC vendor, and what this is doing is it's taking the first 24 bits of the 48-bit MAC address, which is called the OUI, the Organizationally Unique Identifier, and attempting to determine the manufacturer of the network interface card. In this case, it's actually a virtual NIC from VMware, and it wasn't able to determine any vendor for that. And then lastly, a couple of extra fields here called tracker created and extra blocks present, which we won't be using in this particular example. But as you can see, there is a wealth of information that was collected and displayed by this tool. So I hope you see by looking at this the value that LNK files can have in our forensic investigations. These tiny, less than 1K files contain a wealth of information that will prove very, very useful. In fact, as I stated earlier, even if a file has been deleted or even securely deleted from a system, a LNK file referencing that file may still be present, and that in and of itself may be enough to provide the evidence that we're looking for. So in the next and final section of the video, we're going to take a look at the second tool, which is called JumpList Explorer. So let's head over there next. Okay, as we prepare to wrap up this video, we're going to take a look at one final tool called JumpList Explorer. JumpList Explorer has both a GUI-based version of the tool as well as a command line variant called JLE-CMD that works in much the same way as LNK Explorer. Before we jump into that tool though, no pun intended, there's one additional piece of information with respect to jump lists that you need to know. And that is that each application will have a unique AppID that will be included in the name of the .automaticdestinations-ms or .customdestinations-ms jump list file. In fact, you've seen this before. Here are our automatic destinations jump lists on this VM, and you'll see that the one highlighted starts with B8AB and ends with AB2. So that string is the AppID. And in fact, if we go back to this web page I've got pulled up and search for B8AB, you'll notice that it corresponds to Microsoft Excel 2016 64-bit. Now, this particular AppID list is certainly not the only one available on the internet, but it is one of the most comprehensive ones that I've found, and I'll include a link to it in the video's description. So as we jump into the demo for JumpList Explorer, I'm actually going to be picking on this jump list right here, the B8AB jump list. So first, you'll notice I've got a command prompt pulled up and I'm in the JumpList Explorer directory. We'll go ahead and run the JLE-CMD command line version of the tool without any options, and we see that the options that were present with LNK Explorer are present here as well. For example, we can specify a directory or a file, and we have different options for the output format. And there are some additional options here as well. But what we're going to do is run jlecmd.exe. This time we'll specify an actual file with -f, and we'll path to users, my username, app data, roaming, Microsoft, Windows, recent, automatic destinations, and again the B8AB file. We'll use quiet mode. We will write it in CSV format. It's actually a TSV file is what it's going to output. And then we'll save it to the current directory. And you notice that the tab separated value file has been written right here. Now, of course, we can simply open up Windows Explorer and browse to that location. And here is the data that was extracted from that particular jump list. Now, instead of looking at this with Excel, I'm actually going to switch over to the GUI-based version of the tool so I can show you what that looks like, and then we'll sift through some of this data. So let's go ahead and close this. And now let's run the GUI version of JumpListExplorer.exe. And we're going to go up to File, Load Jump Lists. You'll see that I've already navigated to the automatic destinations directory. And we'll again choose the B8AB file. So you'll notice that it neatly organizes all of this. On the left side here, you'll see the different streams associated with LNK file data within this compound data file. So here are 13 streams. And if we click on any one of them, for example, annual financial report, we can see the target timestamps associated with this particular file, along with the file size and the path and some additional information. The same is true with the budget.xlsx file, and some of these other files here as well. We can simply click on any of these streams and gather link file information for any of them. And you'll notice that we even get data such as the host name of the machine, the MAC address, all kinds of information that is extremely valuable, some of which is what we saw when we looked at individual link files, which again, this is basically the equivalent of that data stored in streams within this compound data file. And this tool very, very easily parses it. Now, of course, we could have done the same thing by using Microsoft Excel, using the TSV file that we generated with the command line version of the tool. But I just wanted to show you that this does have a GUI version available as well that neatly organizes all of this data. So that pretty much wraps up this video. The entire intent was to show you the forensic value of link files and jump lists, and I hope we've been able to accomplish that in this video. As always, I would like to thank you for taking time out of your day to watch this. I would greatly appreciate any likes or shares. And if you haven't already subscribed to the channel, please do that. That would greatly help me out. Again, I'd like to thank you for taking the time to watch this. And if you'd like to contact me, I'm available on Twitter at DavisRichardG. If you have any suggestions for future videos or comments or questions, please feel free to reach out to me. My intent is to continue the pace of creating 1 to 2 videos per month. Unfortunately, I can't do it on a weekly basis, as this does take quite a bit of time to put together, especially when we get into more elaborate labs. So again, please continue to look for new videos every month or so. There should be 1 or 2. Thank you again, and I will see you next time.